Listen, everyone thinks an EMP turns every electronic device into a useless brick. And honestly, that's exactly what most survival experts want you to believe, because it sells expensive Faraday cages and EMP-proof gear that you probably don't need. But here's what actually happens when an electromagnetic pulse hits, and this is based on decades of military testing, actual nuclear EMP data from atmospheric tests in the 60s, and physics that doesn't care about your prepper fantasies. There are 4 specific types of devices that laugh in the face of an EMP strike, and understanding why they survive while everything else fries gives you a massive advantage that costs almost nothing to implement. And no, I'm not talking about some obscure military equipment you can't get your hands on. I'm talking about stuff you either already own or can pick up for under $50 total. Here's the thing about electromagnetic pulses that nobody explains properly. An EMP doesn't magically destroy electronics through some kind of death ray effect. What it does is create a massive spike of electrical current in conductive materials, specifically long wires and circuits that act like antennas. The longer the wire, the more current it picks up from the pulse, and when that surge hits sensitive microchips and integrated circuits, it's like shoving lightning through a calculator. The components literally burn out from overload. But, and this is critical, not all electronics are equally vulnerable. The susceptibility depends entirely on 3 factors: the length of conductive pathways in the device, whether those pathways are connected to external antennas or long cables, and how robust the internal components are to voltage spikes. Military EMP testing has shown over and over that certain categories of devices have such short internal pathways and such isolated circuits that the induced current never reaches damaging levels. So, what's the first device that survives? Small, battery-powered electronics with no external connections. I'm talking about basic LED flashlights, the simple ones with just a battery, an LED, and a switch. No circuit boards, no microchips, no fancy controllers. The reason these survive is pure physics. The conductive pathway is maybe 3 inches long total. An EMP induces current based on the length of the conductor acting as an antenna, and 3 inches picks up essentially nothing. The pulse passes right over it like it doesn't exist. Now compare that to your smartphone with its antenna designed to pick up radio signals, its charging port connected to a cable, its complex circuit board with traces running everywhere. That's an EMP magnet. It's designed to be sensitive to electromagnetic radiation because that's how it communicates. Your simple LED flashlight? It's electromagnetically invisible. This has been verified in actual EMP simulators used for military testing. Basic flashlights placed in test chambers with pulse levels that vaporize computers come out working perfectly. The second category is mechanical watches and old-style wind-up clocks. Yeah, I know this seems obvious because they're not electronic, but here's why it matters more than you think. After an EMP, knowing the time becomes critical for coordinating with others, estimating daylight remaining, tracking when systems might come back online. Everyone else is going to be staring at dead phones and digital watches. A $15 mechanical watch makes you the person who knows what time it is, and in a coordination crisis, that's valuable. But there's a deeper reason to understand this category. It teaches you the principle. Anything that operates on purely mechanical principles is immune. Wind-up radios, mechanical timers, non-electronic tools. The EMP can't touch them because there's nothing to induce current into. No circuits, no problem. Now the third device is where it gets interesting. And this is the one that surprises most people. Older vehicles, specifically anything built before the early 1980s, and even more specifically, diesel engines from that era. Here's why. Modern vehicles are rolling computers. The engine management system alone has dozens of microprocessors controlling fuel injection, timing, emissions, everything. Those systems are connected to sensors all over the vehicle through long wire harnesses. It's an EMP nightmare. But older vehicles, particularly those with mechanical fuel injection or carburetors, have almost no solid-state electronics. A diesel engine from the 70s? It's purely mechanical. Fuel pump, injectors, everything runs on compression and mechanical timing. The only electrical component is the starter motor and the alternator, and both of those are so electromagnetically simple and robust that EMP testing shows they keep working. The US military specifically maintained older diesel vehicles for exactly this reason. They knew that in a nuclear war scenario with EMP strikes, their fancy modern equipment would die, but a 1970s diesel truck would start right up. But here's the critical detail most people miss about vehicles. It's not just about the engine. It's about whether the vehicle is connected to anything when the pulse hits. A car sitting by itself with nothing plugged in is relatively protected compared to one that's charging, connected to a battery tender, or hooked to a trailer with its own lighting system. Those connections create longer conductive paths. So even if you have an older vehicle, you want it disconnected from everything during a high-risk period. No battery chargers, no plug-in accessories, nothing. The vehicle's own electrical system is short enough and robust enough to handle the induced current, but add external connections and you've just created an antenna. The fourth category is the one that actually gives you communication capability, and it's so simple it sounds like a joke until you understand the physics. Crystal radio receivers. These are radios that require no battery, no power source. They pull energy directly from radio waves to produce sound. You can build one from $20 in parts, a coil of wire, a crystal diode, a capacitor, and an earphone. And here's the beautiful thing. They survive EMP strikes because they're designed to operate at incredibly low power levels. The components that would normally fry from EMP-induced current are the same components that handle radio wave energy, and they're built to be sensitive without being fragile. Military testing of crystal radios showed they continue functioning even after EMP exposure that destroys everything else. Now, you can't transmit with a crystal radio, it's receive only. But after an EMP, when every other communication device is dead, being able to hear emergency broadcasts, military communications, or coordinated recovery information is massive. But let's talk about what this really means practically. The pattern you're seeing across all four of these device categories is the same: short conductive pathways, no external antennas or long cables, and either purely mechanical operation or extremely simple circuits with robust components. This is your selection filter for anything you want to survive an EMP. When you're looking at gear, ask yourself, does this have a long antenna or connect to long cables? Is it full of sensitive microchips? Does it rely on complex integrated circuits? If yes to any of those, it's vulnerable. If it's simple, short, and either mechanical or using basic robust components, it survives. Now here's where people make the biggest mistake. They assume they need to Faraday cage everything, and while that's not wrong, it's inefficient. A Faraday cage works by blocking electromagnetic fields, but it only helps if you've got devices worth protecting that are actually vulnerable. Putting a mechanical watch in a Faraday cage is pointless. It's already immune. Putting your smartphone in one makes sense, except your smartphone is useless without infrastructure. Even if it survives, there are no cell towers, no internet, no GPS satellites functioning. You've protected a brick. The smarter move is to focus your Faraday protection on things that give you capability in a post-EMP environment and are actually vulnerable. A small AM/FM radio with fresh batteries and a Faraday cage gives you receive capability if any stations come back online. A basic walkie-talkie set, the simple kind with minimal circuitry, protected and ready to go for short-range communication. And here's the thing about those four device categories I mentioned. You should have all of them right now, not in a Faraday cage, just available. A couple basic LED flashlights in a drawer, a mechanical watch you actually wear. If you've got an older vehicle, you're already set. If not, knowing which ones are EMP resistant changes your vehicle buying strategy completely. And a crystal radio kit? You can literally build one in an afternoon following free online instructions, and it sits there forever, requiring nothing. No batteries to replace, no maintenance, just ready. The real survival advantage isn't having a bunker full of protected electronics. It's understanding what actually survives and why, so you're not dependent on protection methods that can fail. Faraday cages were great until you open them to use the device, and then it's exposed. Or the cage wasn't constructed properly and it fails. Or you need the device immediately and it's buried in your protection setup. The devices that are inherently EMP resistant because of their design, they're ready instantly, always, without any protection needed. That's the difference between theory and practice. Everyone talks about Faraday cages. Almost nobody talks about just selecting gear that doesn't need protection in the first place. And when an EMP actually hits and you watch everyone frantically digging through their Faraday setups, hoping they built them right, you'll be the one with the working flashlight, knowing what time it is, possibly with a working vehicle, and able to hear what's being broadcast. Not because you spent thousands on EMP-proof gear, but because you understood the physics and chose simple, robust tools that the pulse can't touch.